You might recall in the movie Terminator that Skynet is a self-aware artificial intelligence system that gets so fed up with humans that it initiates a nuclear war and later sends Terminators, e.g. Mr. Schwarzenegger, back in time to ensure its own survival and dominance. You may also recall that Robot Arnold traveled back in time from the year, get this, 2029. Hilarious! That's like 4 years from now. Good thing it's all just make-believe and can't really happen. Artificial intelligence is everywhere right now, powering search engines, writing emails, generating art, and even helping doctors diagnose diseases. But how does it actually work? If you've ever felt curious but a little overwhelmed by the tech behind AI, you're not alone. This episode is all about unpacking machine learning, the fundamental underpinnings of AI, in a way that's clear, simple, and jargon-free. You don't have to be a programmer or have a computer science degree. Trust me. We'll walk through what it is, how it works, where you're already seeing it in your daily life, and why it sometimes gets things hilariously or alarmingly wrong. Let's dive in. I'm Chris Roman, and I'm nerd adjacent. So, what is machine learning really? Well, let's break it down. Machine learning is a way for computers to learn from experience. Instead of being explicitly programmed to do a task, a machine is fed data, learns patterns in that data, and gradually improves its ability to perform a task on its own. Think about how you learned to recognize different types of fruit as a kid. No one handed you a detailed manual on apples and oranges. You just saw a lot of examples. Someone pointed and said, "This is an apple." Later, someone handed you something else and said, "This is an orange." Over time, without needing to be told every time, you started to know which was which. You didn't memorize a list of rules like apples are red and round. You just saw enough of them that your brain started to recognize the patterns. Machine learning works in a similar way, only with digital data. Let's say we want a computer to recognize pictures of cats. We don't write code that says, a cat has 2 ears, whiskers, and sometimes stripes. Instead, we show it thousands of photos labeled cat and not cat. Over time, it starts to learn what cat-like features look like, and eventually, it can look at a brand new photo and say, "Yep, that's a cat," or "Nope, not a cat." It's not memorizing the images, it's learning the patterns it sees in the images. So when we say a machine is learning, what we really mean is it's making connections between inputs, like photos or words, and outputs, like "that's a cat," or "this email is spam," and getting better at it the more data we give it. It's the same principle behind voice assistants understanding your questions, or how your phone unlocks when it sees your gorgeous face. It's not about giving computers instructions, it's about giving them examples and letting them figure it out. So now that we know more about what machine learning is, we can talk about the ways in which that learning is structured. First is supervised learning. Think of this like giving a student a practice test where the answers are already filled in. They look at the question and the correct answer over and over until they learn how to find the right answer themselves, a lot like flashcards. In machine learning, this means giving the computer data with labels. For example, a list of emails that are marked spam or not spam. The machine learns what spam looks like, and eventually, it can recognize it on its own. Next is unsupervised learning. This is like dumping a jigsaw puzzle on the table without the box. No picture to guide you. You don't know what you're trying to build, but you start grouping similar pieces together, maybe by color or shape. That's what unsupervised learning does. It finds patterns in data that haven't been labeled. In the real world, this kind of learning is used for things like grouping customers who've made similar purchases for use in marketing, or detecting unusual behavior when you use your credit card. Or maybe for identifying the Last of Us, still fighting in their resistance. And finally, reinforcement learning. Imagine training a dog to sit. Every time they sit, when you say sit, they get a treat. Over time, they learn sitting equals reward. Reinforcement learning works the same way. The machine tries things, gets feedback, positive or negative, and gradually learns what actions lead to the best outcomes. This is how autonomous vehicles improve their decision-making, learning when to speed up, slow down, or avoid obstacles, all based on past experiences and simulated training. Though this does not mean I'm any more excited to get into a self-driving car than I was yesterday, which, incidentally, could be labeled as not interested. You might be thinking, okay, cool, but how does this actually show up in my life? Let me give you a few examples. When Spotify suggests a playlist you'll probably love, Dua Lipa, for instance, that's machine learning. Apps like Google Maps or Waze use machine learning to suggest the fastest routes, learning from real-time traffic, construction, and user behavior to constantly update their suggestions. Even your phone's voice assistant, like Siri or Alexa, is powered by machine learning to understand what you're saying, even if you're ordering another case of Flamin' Hot Funyuns with a mouthful of Flamin' Hot Cheetos. These systems are constantly learning from your actions to get better, faster, and more accurate over time, despite how creepy that might sound. Before we wrap up, there are a few clarifying points about machine learning that I thought were important to mention. Everything you've heard about AI recently might lead you to believe that machines are becoming intelligent, like humans, or, God forbid, super intelligent like dolphins or raccoons. But machine learning doesn't mean machines are thinking. They don't understand context, emotions, or intentions. They don't know they're learning. They're just adjusting numbers behind the scenes to get better at a narrow task. Your email filter might be great at spotting spam, but it doesn't know what an email is. It's just making a best guess based on past data. Machine learning works best on specific, well-defined tasks, like recognizing faces or recommending movies. But it often struggles with ambiguity, creativity, and common sense. If the problem isn't clear, or there's not enough data, even the smartest algorithm won't help. You might also assume that more data always means better results, but that's not always true. If the data is bad, biased, incomplete, or just irrelevant, then piling on more of it doesn't help. In fact, it can make things worse. It's like trying to fix a bad recipe by doubling all the ingredients. More of the wrong stuff won't save the dish. There is an upper limit to how much sriracha you ought to be using. So, the quality of the data matters just as much, if not more, than the quantity. In the real world, machine learning isn't Skynet plotting world domination. It's more like a diligent intern learning from examples. It's a tool, a powerful one, that helps computers recognize patterns, make predictions, and automate certain tasks. But it has limits. It can get things wrong. It doesn't understand in the way we do. And it's only as good as the data it's trained on. So, whether it's transcribing a meeting, powering voice assistants, or recommending your next movie, this one seems obvious, machine learning is already woven into everyday life. And the better we understand how it works, the better equipped we are to use it and control it. If you enjoyed this episode, share it with a friend who's curious about technology or is having trouble sleeping. Leave a review wherever you listen to podcasts. And if you've got questions or show ideas, I'd love to hear them. Until next time, thanks for listening. I'm Chris Roman, and I'm just kidding. I'm nerd adjacent.